Okay, so the third example here is of the first derivative analysis is with this trigonometric function f of x is x squared plus cosine x. But now we're only graphing, or we're only considering this function on the interval from 0 to 2 pi. So this procedure is the same. We're going to need to recall our wonderful glory days back in trigonometry when we're going to solve these trigonometric equations, but we'll get there. So the first derivative, remember this is x over 2. This is the same thing. X over 2 is the same thing as 1/2 times x. The derivative of 1/2 times x, this is the same as any other linear function. The derivative is the coefficient, or a linear term. The derivative is the coefficient. So the derivative is 1/2, and the derivative of cosine is minus sine of x. And we're going to find the critical values. And type 1, that's where the derivative is equal to 0. Set this derivative equal to 0, that's where we're going to work with our solving trigonometric equations. So we have 1/2 minus sine of x is equal to 0. I'm going to subtract the 1/2 across, multiply both sides by 1/2. Subtract the 1/2 across, multiply both sides by 1/2. And so this is equivalent to the sine of x is equal to 1/2. We're going to solve this in the interval from 0 to 2 pi. And so first we're going to do a quadrant check. Well, the quadrant check, sine is positive in quadrants 1 and quadrant 2. So we have two solutions, a quadrant 1 and a quadrant 2 solution. The reference angle, the question is, when does sine equal 1/2? We know that's the special triangle, 30, 60, 90. However, we're in radians here. You would use 30 degrees if you were in degrees, but we're doing everything in radians. And so x reference is pi over 6. So we have a pi over 6 reference angle in each of quadrants 2 and 3. So the quadrant 1 solution, in quadrant 1, x reference is the same as x. So that gives us, in quadrant 1, x is equal to pi over 6. And in quadrant 2, reference angle of pi over 6 in quadrant 2, x is 5 pi over 6. And so the number line is divided. The difference is we don't go all the way down to infinity and negative infinity because we're only going from 0 to 2 pi. So 0 is the lowest value, 2 pi is the highest value, and our two cut values are pi over 6 and 5 pi over 6. And so we have 1, 2, 3 intervals over which we need to do this increasing and decreasing. So we choose, just the same as before, choose representative values from each of these regions. Now, with the trigonometry, this is a little bit different. I need an angle between 0 and pi over 6. You may choose any angle in that interval. I'm going to choose the midpoint. I'm going to use pi over 12, not because it's the best, but because it is obviously between 0 and pi over 6, the midpoint. So I'm going to use pi over 12 for the first representative value. Now, in this interval, this can be, this is pretty clear that, remember, here's the unit circle. Here's pi over 6. Here's 5 pi over 6. So we're allowed to use any convenient angle between them. I'm going to use pi over 2 as a convenient angle to work with that's between pi over 6 and 5 pi over 6. And then between 5 pi over 6 and 2 pi, any convenient value in this interval will suffice. I'm going to use 3 pi over 2. You may choose any value in any of those intervals you like. Notice I'm also choosing, in this interval, I'm choosing pi over 12. So I've chosen pi over 12 in this small interval. I've chosen pi over 2 in the interval between pi over 6 and 5 pi over 6. And in this largest interval, I'm choosing 3 pi over 2. So it falls now to compute the derivative at each of those values. And really, again, all we need to know is whether that value is positive or negative. The first is at pi over 12. The next is at pi over 2. And the last is at 3 pi over 2. And I need to evaluate the second derivative there. So that would be 1/2 minus sine of pi over 12. 1/2 minus sine of pi over 2. And 1/2 minus sine of 3 pi over 2. Well, of those, pi over 12 is the trickiest bit, and I just did the same thing you would probably do. I just resorted to a calculator. So, this, if you compute this, 1/2 minus sine of pi over 12, this works out to be approximately 0.241, as I recall. I'm going to double check that. Just go off to the side, find the calculator. I want sine of pi divided by 12, and I want to take 1/2 minus that. And yes, it's negative 0.241. It's negative 0.241. Well, negative 0.241. The 241 is not the main item, it's the negative. Negative 0.241 is less than 0, and so that means in that interval, this function is decreasing. At pi over 2, well, we know sine of pi over 2. Sine of pi over 2 is 1. So 1/2 minus 1 is negative 1/2, which is less than 0, so the curve continues to decrease. Oops. The curve continues to decrease in that interval. And then at 3 pi over 2, this is 1/2 minus sine of 3 pi over 2 is negative 1. Well, that's 1.5, which is bigger than 0, so the curve in that interval is increasing. So it's decreasing. It continues to decrease between pi over 6 and 5 pi over 6, and then, and then it is increasing. So we have one potential relative minimum. And so let's state our solution here for the increasing, decreasing. F is increasing on only one piece of this. That's from 5 pi over 6 to 2 pi. And F is decreasing on each of these other two intervals. Again, it's best not to combine them. In this particular case, you may, but it's usually best not to combine them. So it's increasing on that interval and decreasing on those two. And we potentially have a relative minimum. So there is a relative minimum at 5 pi over 6, comma, don't know yet. So we could see if we can find that value. A couple things to bear in mind. Once we've found the increasing and decreasing, we no longer use the first derivative. The first derivative part ends here. Once we find this increase and decreasing, it's finished. Now we go back to using the original function. So the function value at 5 pi over 6, f of 5 pi over 6. This is a little bit messy, but hang in there. It's 1/2 times 5 pi over 6 plus cosine of 5 pi over 6. Well, that's 5 pi over 12, top times top, bottom times bottom, plus, and now we need cosine of 5 pi over 6. Well, we know 5 pi over 6 is a quadrant 2 angle, and we know cosine is negative in that quadrant. And we know cosine of 5 pi over 6, the reference angle is pi over 6. And so we should know that cosine of any angle whose reference angle is pi over 6 is the square root of 3 over 2. And so the function value is 5 pi over 12 minus the square root of 3 over 2. It is sufficient to simply leave it like that. Just leave it in this exact form. And so the relative minimum is at 5 pi over 6, comma, just write that expression in as the y coordinate. 5 pi over 12 minus the square root of 3 over 2. And that is the relative minimum for that function. One small detail, I don't get full credit for my work here because I forgot to do type 2. Type 2 critical values, that's where the derivative does not exist. However, there are none because this is this original function, the derivative. The derivative is a trigonometric function involving sines and cosines. So if the only function involving is sine and cosine, there are none because sine and cosine exist everywhere on the real number line. This is because it's a sine function. So there are no type 2 critical values. So intervals of increase, decrease, relative minimum.